What is the mass of 2,9 times 10 to the power 23 carbon dioxide molecules? Now let's do it again in two different ways. One, let's take the mass as grams, and another way, let's do it with the mass being AMO, because it wasn't specified, so let's calculate both. I think if they don't specify, they would probably mean you must do it in grams, because this is a large number of carbon dioxide molecules, so you would be able to get a reasonable value in grams. It's only when we have a small number of molecules that we would use AMO, because then grams would give too small a number. But in any case, just as an exercise, let us get it both in grams and in AMO. Do it yourself first. How many grams is the mass of 2,9 times 10 to the power 23 carbon dioxide molecules? Our unit factor has carbon dioxide molecules at the bottom, grams at the top. Notice not moles of carbon dioxide, just carbon dioxide. Now we know from the periodic table that the molar mass of carbon dioxide is 44 grams. We've worked that out a few times, so I'm not going to do it over. 44 grams is the mass, careful, of 1 mole of CO2. So how many CO2? 1 mole is 6,02 times 10 to the power 23 CO2s. Because remember, we don't want mole CO2 because we're not given mole CO2. There's no mole written there. So we need CO2. So 44 grams is the mass of so many CO2s because that is 1 mole. And then we can find the answer. 2,9 exp 23 multiplied by 44 divided by 6.02 exp 23 gives us the answer of 21,196. So that's 20 grams. And now let's interpret the question as saying, what's the mass in AMO? How many AMO is 2,9 times 10 to the power 23 carbon dioxide molecules? Our unit factor must have carbon dioxide molecules at the bottom and AMO at the top. And we know that the molecular mass of carbon dioxide is 44 AMO for every molecule. So 1 molecule of carbon dioxide, now it's not a mole, now it's a molecule. 1 molecule of carbon dioxide has a mass of 44 AMO. Notice the difference between the top and the bottom here. In the top we say 44 grams is the mass of 6,02 times 10 to the power 23 carbon dioxide molecules. In other words, a whole mole of carbon dioxide. In the bottom, we say 44 AMO is the mass of 1 single carbon dioxide. And that's because, remember that these numbers down here, they are both molar mass, which is what we are using up at the top. Here, this is molar mass, meaning the mass of a whole mole. And then the unit is grams. And these numbers also mean atomic mass. That's what we're using down here. And that refers to the unit AMO, and then we're speaking only about 1 molecule and the masses of the atoms in it. 2.9 exp 23 multiplied by 44 is equal to 1,276, which is 1,28 rounded off, times 10 to the power 25, and the unit is atomic mass units. These two values here are the same as one another, just in 2 different units. And you can check that by dividing this value here by Avogadro's number. So divide by 6.02 exp 23, and it gives you this number over here, 21,20 when rounded off. And that's because that's a conversion factor between AMO and grams. What's the mass of 6,1 times 10 to the power 24 lead oxide molecules? I'm just going to interpret the question as asking how many grams do we have when we have 6,1 times 10 to the power 24 lead oxide molecules. And we have our conversion factor with lead oxide molecules at the bottom, grams at the top. Notice it's not moles lead oxide, it's just lead oxide. Molar mass of lead oxide, 207 plus 16, 223 grams per mole. Be careful, top and bottom must refer to the same thing. 223 grams is the mass of 1 mole. So this must be 1 mole down at the bottom, but we don't want mole because our unit is not mole lead oxide, it's just lead oxide. So we must write 6,02 times 10 to the power 23 because that's how many lead oxides are in 1 mole. 6.1 exp 23 times 223 divided by 6.02 exp 23 is equal to 225,96 grams. Now I'm going to do that over, showing how you can do it in 2 steps if you prefer. How many grams is the same as 6,1 times 10 to the power 24 of lead oxide. So we know that lead oxide's molar mass is 223 grams per mole. 223 grams of lead oxide is the same thing as 1 mole of lead oxide. So that has helped us get to our goal to an extent because it's introduced here grams, which is what we want at the end. So that's good. But it's also brought in a unit we didn't want, mole lead oxide. We wanted lead oxide, not mole lead oxide. So we cannot cancel the top given unit yet. So we need another step in our process. And that needs to get rid of this unwanted lead oxide unit and also get rid of the unwanted given unit, lead oxide. So we ask ourselves, how many lead oxide is how many mole? 1 mole is the same thing as 6,02 times 10 to the power 23. So here we cancel away mole lead oxide, there we cancel away lead oxide. And can you see that it's exactly the same as this top method? It's just that this step here has been split into 2 to aid our thinking. So if you can do it in this one step over here, well, that's quicker. But if you need to split it, that's also fine because it still gives you exactly the same answer, 225,96. Now it asks how many lead oxide molecules have a mass of 42,0 grams. Try this yourself first. How many lead oxide molecules have a mass of 42,0 grams? Now maybe you can do this all in one step, but I think I'm going to do it a bit of a longer way, just in case people need that extra step. So we know from the molar mass of lead oxide that 1 mole of lead oxide has a mass of 223 grams. Notice I can write it like this, or gram dot mole to the minus 1. It's the same thing. So I can get rid of this unit grams, which is very nice. 223 grams is the mass of 1 mole of lead oxide. But I cannot just stop there because I've now introduced a unit that I didn't actually want, mole of lead oxide. I want lead oxide, not mole of lead oxide. So I need to have another factor to get rid of that unwanted unit, mole of lead oxide, and introduce the required unit, lead oxide. And I know that 1 mole is 6,02 times 10 to the power 23 particles. In this case, particles of lead oxide. So moles of lead oxide cancel, and I'm left with my required unit, lead oxide. 42 divided by 223 times 6.02 exp 23 is equal to 1,133, rounds off to 1,13, times 10 to the power 23 lead oxide molecules. Notice I could have combined these two by just saying 6,02 times 10 to the power 23 lead oxide over 223 grams and left out the moles. But maybe you would need to do it in 2 steps just to be able to think it through more carefully. It's your choice. How many ammonium nitrate formula units have a mass of 118 grams? Try to do this yourself. How many NH.NO formula units? Ammonium nitrate is an ionic substance, that's why we say formula units rather than molecules, have a mass of 118 grams. Now again, I'm going to do it in 2 steps. You don't have to. You can do it in 1 if you can, but I'm thinking it through. I know that the molar mass of ammonium nitrate is 2 times 14 plus 4 for the hydrogen plus 3 times 16 for the oxygen, 80 grams per mole. So 80 grams is the mass of 1 mole of ammonium nitrate. And I'm happy to be able to cancel off the grams there, but I cannot stop there because I'm left with the unit mole ammonium nitrate, but I was asked ammonium nitrate, not mole. So I have to have another conversion factor which has mole of ammonium nitrate at the bottom, and the unit I actually want, ammonium nitrate, at the top. And I know that 1 mole of anything is 6,02 times 10 to the power 23 of those particles. So mole ammonium nitrate cancels away and ammonium nitrate is introduced, and I can calculate this. 118 divided by 80 times 6.02 exp23, and it gives me 8,879, which rounds off to 8,88 times 10 to the power 23 formula units of ammonium nitrate.